Hi everyone, it's Coach Fred here, and today I'm going to be reviewing something you've learned in your class, dividing polynomials. And I'm going to use two methods. I'm going to do dividing polynomials using long division and synthetic division. Okay, so when we're dividing polynomials, we're going to divide 2x minus 1 into 2x cubed minus 7x squared plus 11x plus 5. Now, you can see clearly that I have an x cubed, an x squared, an x, and a constant. But sometimes there's a missing term, and I want to remind you that that I was dividing into 11, like something like this. You always want to make sure you put a placeholder in for every term from the highest degree down. So I would really need to consider it or rewrite it like this. Put in that placeholder 0. So we always want to remember, if we're going to do long division or synthetic division, that we have to have every single term covered from the highest degree all the way down to the constant. Okay, so now we're going to divide. Okay, so we look at the first term here and the first term here, and we divide 2x into 2x cubed. One way of thinking about that is to say to yourself, 2x times what? So 2x times what would give me 2x cubed? And that would be x squared. All right, so x squared is going to get placed right above the term with x squared. That's the way I do it. It just makes it a little bit easier and cleaner for me. All right, so then I'm going to take x squared and I'm going to multiply it to the entire term, 2x minus 1, okay? All right, so that's going to give me 2x cubed, those should always work out to be the same, minus x squared. All right. Now we subtract. When we subtract, this becomes negative. This would then become positive. All right, so these are going to cancel to 0, and then we're going to get negative 6x squared. We're going to bring down the 11x. All right, and now we're going to start over, and we're going to say 2x times what would give me negative 6x squared, which would be negative 3x. Okay, so now we multiply negative 3x times the entire term. Okay, so that's going to be negative 3x times 2x, which gives me negative 6x squared. Then negative 3x times negative 1 is going to give me positive 3x. Then we subtract. So this is going to become, if we subtract, this becomes positive, this becomes negative, and then we get 8x, and we bring down the 5. Okay, so then again, we go through the process one more time. So 2x times what is going to give me 8x? So that would be 4. All right, so then we multiply the 4 times the 2x minus 1, and we get 8x minus 4. We subtract. So this becomes positive, and we get a remainder of 9. So that is a remainder. All right, we take that remainder and we write it over the original divisor of 2x minus 1. All right, but what does this actually mean? I want to make sure that you have a clear understanding of what this means. If I took this factor, or this term, and I set it equal to 0, that's going to give me 1/2. So add an x of 1/2 on this graph, on the graph of 2x cubed minus 7x squared plus 11x plus 5. If I plug 1/2 in, I'm going to get 9. So that point actually lives on the graph. It's just not an x-intercept. If I got a remainder of 0, then we'd know that this is a factor of the polynomial, and so it would be an x-intercept. 1/2 would be an x-intercept in that case, okay? All right, so that's polynomial long division. Let's talk about synthetic division. Now, synthetic division is nice and easy, except you can only use it in one case. The original divisor has to be a linear term. If it is quadratic, you cannot do that. All right, so to use long division, you find the actual factor. So you set p minus 3 equal to 0, and you get 3. So p is 3. So I'm going to take 3, and I'm going to put it in a little box. And then I'm going to take the coefficient to every single term and write it horizontally across on the other side of that box. So I'm going to do 3, 2, negative 32, and 2. All right, so the process is we bring down the 3, we make a line. Okay, so here's my 3. Now I multiply 3 times 3, I get 9, and I place it right up here, and then I add down, and I get 11. All right, then I do 3 times 11, which is 33, and then I add down, and I get 1. And then I do 3 times 1, okay, which is 3, and then I add down, and I get 5. So 5 is my remainder. So I actually know that the point 3, 5 lives on this graph, on the graph of 3p cubed plus 2p minus 32p plus 2. All right, but how do I write this as, like we did on the other one? Well, this value here, we call it the depressed polynomial, okay? So we work our way down 1 degree, and these are our new leading coefficients to our depressed polynomial. So our depressed polynomial then would be 3p squared plus 11p plus 1, and then our remainder would go over our original divisor. So you can see that this is a really nice method to use, but it's just that it only works when the original divisor is a linear term, okay? All right, so hopefully that was a helpful video, and have a great day.